So what we're going to talk about today, these are the topics of the agenda for today's webinar. We're just going to start out with the overview of the turn module, and then we're going to be talking about how we actually define a turned part in our system, and then also the setup, the part setup. How do you set it up to get the machining started? We'll talk about tooling, defining turning inserts for tooling. And then we'll actually get into the operation types, the different operation types, which is basically roughing and finishing, and then other special operation, turn operation types that we have in our system. And then we'll also talk a little bit about the simulating and posting of turn operations. So pretty much a basic introduction to our turning module. So Don, I'll be joining by Don. Sorry, I didn't introduce Don LaCourse. He's our senior product engineer, support engineer, and he's going to be doing the presentation as well as the demo. So Don, go ahead, please.
Hello, everyone. Thanks for joining us today. And what I got on my screen right here is just a basic view of what our turning module does. Our turning module is a 2.5 axis CNC lathe module. If you look at the view on the far right, you'll see a typical 2.5 axis lathe where you got a rotational axis and then the tool axis direction axis. So on the left, you see two models. We're going to be showing you this model also in the demo. Pretty complex model. This model has ID holes, ID grooves. It's got OD roughing and OD finishing. It's got OD grooves, and then also it's got an OD parting off on the back. So we're going to be going through this as well.
For those of you who are not familiar with ID and OD, OD stands for outer diameter, and ID stands for inner diameter.
Yes, yes. Okay, let's go to the next slide. Now, here we're going to talk about how the part should be oriented for turning. If you load a part or if you import a part and it's not in this orientation, you need to orient the part as it's shown here, and we'll go over that here. On the left side, we have the part back face, which is aligned with the world coordinate system origin. So in the world coordinate system origin, when you first load your model, you'll see your triad, your X, Y, and Z. Z is up, and X is to the right, and the Y is pointing from you. You're looking in the same direction as the Y axis. So in the middle view here, you see you need to move your part, the center of your part, the center back face of your part to the world origin, so that the geometry is in the positive XY quadrant of the world coordinate system. And then on the right, we just see the right side view showing the world coordinate system. A lot of new users get this incorrect, and if this is incorrect, then you're just going to get errors when you try to set things up and run operations. So you need to verify that you're in the correct orientation for turning. Now, the next step after you have your part oriented and positioned correctly based on the origin of the CAD system, the WCS, you need to define your part. Even though you got the part geometry, the part isn't defined yet in the turn system. So you actually have to define it. And this is a menu option. I'll go through that. Here's the dialog on the left. You can define your part either by selecting surfaces or selecting curves. So in the middle, we see we have a revolved solid. So we could select the solid itself to define the turn part, or you can, if you have a section view of your solid, if you just, in the CAD system, if you just cut a section of your solid on the XY plane, you'll see a section view of the part. You can use that section view also to define your turn part. So you have, this dialog has two different options you can use, surfaces or curves. And once you pick save, The profile will be generated by the turn system and displayed, and your part will actually be shown on the screen, as you see on the right here. It's kind of, you're going to say something, Joe?
Yeah, I had a quick note on this. You know, one of the things we're doing here if you select the cross section, we're basically creating a revolved solid. That's pretty much standard. But an important point in the surface model, if you can have a solid model like the one Don's got in the middle of that graphic, that's also happens to be a revolved solid. But we can also handle solids that are not revolved. So if you have, let's say, a protrusion on that particular solid, something sticking out of it, and you select that solid model as the part geometry, then what we do internally is we take that solid model and actually revolve it, and then create the profile or the part geometry based on the completed revolution. So even though you might not have a completely revolved part, we are able to resolve that, and that's why we have the solid model as an option for you to select as the part geometry. Hope that makes sense.
Okay. Again, if you guys got any questions, please go ahead and add them to the questions tab in the GoToMeeting dialog. Okay, so let's continue. We oriented the part, we defined the part. So now we have a part in the turn module. So let's keep going here. Now, what we're looking at here is we're showing you the part when it's completely programmed. So we have the part in the middle, it's oriented correctly. The world origin is on the back face of the part. If you look on the far right section view of the part, you'll see the world coordinate system. The part rotational axis is extending along the x-axis in the world coordinate system. Now, this is before you define any work zeros or program zeros or anything, just orienting your part and looking at it. It should extend along the x-axis of the world coordinate system. So you see a cross section of the part, and this is actually a cut material simulation that you're looking at here on the far right. If we go to the far, on the far right, if we go to the far left, you see the completed machining job for this part. So we're just going to go over it briefly. I'll show you these in the demo as well. Working our way down from the top, we have the machine defined, we have the post defined, we have the part defined, and we have our stock set as a cylinder stock. And then after that, we have a work zero. I'm going to show you how to do all of these in the demo. But then we break it down into drilling. We're drilling out, we're roughing the inside of this core with some drilling operations. And then we're doing some groove roughing, groove finishing, turning, roughing, all the way through all the operations it takes to complete this part, as you see on the right side. So the first thing that after you define the part is to define your stock. Your stock, by definition, turning module is going to be a revolved turn stock. You can set the dimensions of your stock, your radius, and your length based on your part dimensions. If you look at here, you see that we have the stock aligned to the back face of the part, and it extends to the right. It extends a little bit further than the part itself, and you see on the right an isometric view of the part and the stock geometry. Now, you have your part defined, you have it positioned, the back face on the right side of the world coordinate system, your part is positioned, flushed with the world coordinate system. The rotational axis extends along the x-axis, as we mentioned. Now what we're going to do is define the work zero or the program zero for the turn machine. So if you look at on the right side face of the stock, you see that we have an MCS or work zero. And the work zero, this defines the actual turning axis for the turning operations. So in your work zero, your Z is extending along the rotational axis. Your X is extending this way. This is the direction of the feed that your tool will access the part, and then the Y is pointing up. When you create a work zero, if it does not look like this, oriented like this, you need to double check and make sure it is, because you won't be able to complete any operations. You'll probably get some errors, as I mentioned. So A, the part needs to be oriented with the world coordinate system on the right, and B, your work zero needs to be positioned on the front face of your stock with the Z-axis pointing in the positive direction of your rotation.
Actually, the work zero doesn't have to be on the right side. It can be located anywhere to the right of the WCS. So,
okay,
yeah. But the important point is the work zero also defines the coordinate system, also the turning coordinate system.
mm-hmm.
So if you notice the blue arrow, which is the Z-axis of the turning system, is the revolving axis. So does any move in Z as far as the turn is concerned is going to be along that axis. And then the X is going out in this direction. So which is typically the X and the Z are typically the coordinates used in the turning module.
Okay. Okay, so and then in the middle we see the machining job. We see the work zero defined, and it's got to be at the very top of your setup. The first operation under your setup is your work zero. If you don't have a work zero, I guess, Joe, it'll default to the world coordinate system for the work zero. Correct me if I'm wrong in that.
Yeah,
okay.
But that's incorrect.
Yeah.
So it's not going to work. So
you got to have your work zero defined. Okay, so let's go to the next slide. Now, we mentioned in this part we have an ID profile, and the easiest way for this part to rough out all this material is to do a few drilling operations. And in the turning module, it handles various types of drilling, tapping, boring operations, same type of hole making operations as in the mill module, but it's oriented for turning. And you also obviously can do other types of operations to complete this part. But in this slide, we're using 3 drilling operations to rough out the ID of the part, so we can come back and do some ID finishing. Now, there's, you got to have access. Obviously, if you have an ID, you need to have that accessible in order to do any type of ID roughing or ID finishing with an insert. So you have to clear that material out of there first. Okay, so let's go on to the next slide. Here, on this particular part, we have a groove on the front face that is performed with a groove roughing and groove finishing operation. You could do this with a boring operation as well, but we're doing it with a groove operation. Now, since we have the ID already roughed out with our drilling operations, we can now come in here with an internal diameter finishing operation with an insert. So we get a blow up view over here on the right showing the finishing operations in 3 passes. Again, you got to have this accessed, roughed out in order before you do this operation type, obviously, or you'll crash the insert. So let's go into the next slide. Now, for this particular part, it's a relatively complex part. You're not going to be able to rough it out with one operation. Obviously, if you look in the top middle section view here, you'll see that we have the first roughing operation with the insert positioned in the forward position. The insert can be in the either facing forward or facing backward. So you see the first operation, the insert is facing forward, but it cannot get this area in the back. So that is a blind spot for the tool. It cannot locate that based on the orientation of the insert. So you got to do one operation, then you got to do a second operation with the same insert, but oriented OD backward, so that it can cut in this back side and rough it out. If you got any questions about roughing, go ahead and ask them in the questions panel. And of course, if you look at the red here in the middle, that is your in-process stock. You'll see that the tool cannot get into the full depth of the groove because of the orientation of the insert. So we only roughed out part of this groove. So we're going to come back in with some groove roughing and groove finishing to clean that groove up. And as well on the front, you have some stock material left on the front that you can clean up with a front facing operation. So this is what the part will look like after you have your ID roughing with your drilling, your ID finishing, and then you're doing OD roughing on the outside. Now we're going to do some OD finishing, front facing finishing. That's what you see right here. We're finishing the front face of the part. We only have to go past the groove. Obviously, we don't need to face it all the way in. So we're doing a front face to finish off the front of the part. And then on the next two operations, again, similar to roughing on the OD, the outside diameter, you have to have two operations for finishing, because in the first operation, you can't get this back side. So you're doing one operation on this front side, and then you're doing a second operation with the insert in a different orientation and finishing the back quadrant there. Now here to finish out this part, we're doing some groove roughing and some groove finishing, and then also or parting it off on the back side of the part.